We'll be discussing about the topic number properties. Number properties is one of the most important topics of GMAT, and approximately 5 to 6 questions out of a total of 31 questions can be expected from this topic itself. So this statistics speaks of how important this topic is. While we start this topic, it's very important for us to understand the basic terminology of the numbers. So I'll quickly start discussing from the basic terminology, and then we'll proceed and then see how exactly can that terminology be used to better comprehend the questions. Alright, beginning from here. First of all, let me discuss that there are several terms. For example, there is something called real numbers. So you have to always keep thinking that what are real numbers and what are non-real numbers, right? GMAT usually says that x is a real number. So what should we understand about the real number? So let me quickly give you the definition. The real numbers are all the numbers which can be represented on the number line. Now, how do you know whether a number can be represented or cannot be represented on number line? So just to give you an understanding, see, the number line is, first we have 0, to the right we have 1, 2, 3, 4, and to the left of the number line we have -1, -2, -3, -4, etc. So this is called the number line. And virtually every number can be represented on the number line. So that's also is one thing. So what kind of numbers cannot be represented on the number line? That's a very interesting question for us to discuss. So the numbers which are negative values inside the square root are the numbers which cannot be written on the number line. Often we learn these numbers from the term imaginary numbers. However, GMAT does not use the term imaginary numbers, and therefore we should just understand that the same imaginary numbers are called non-real numbers, because if there is a negative value inside the square root, then to simplify this further, we have to bring in iota in the picture, because iota has a value square root of -1. So that number becomes non-real number. There have been questions made on every concept that we are going to discuss here in this video. However, the type of questions that we are going to come across, you will see when the exercise comes in. Now, let's start. What is a real number? Real number further can be categorized into two broad categories. The first is called as rational numbers, and the second is called as irrational numbers. Now, let's understand what are rational numbers and what are irrational numbers. As the term itself suggests, that rational numbers are the numbers which can be written in the ratio of two integers. That means the numbers which can be written as a ratio of two integers, p by q form. Then the number is called rational number. Here, the denominator cannot be equal to 0. That's one thing that GMAT specifies. Often we learn that if the denominator is 0, then the number becomes infinity. But GMAT does not recognize any term like infinity. GMAT says that the number is not defined if the denominator is ever 0. So GMAT never gives you an opportunity in which the denominator can be 0. So I define rational numbers as numbers which can be represented as a ratio of two integers where the denominator is not 0. On the other hand, irrational numbers may be described as the numbers which cannot be written in the form of p by q, where p and q are both integers. But now the next question is, how do we know whether number can be written in the form of p by q or not? For example, if we have a number, for instance 1.2357, something like this. So how do we recognize whether this number will be a rational number or an irrational number? So that can be clarified by the two properties which are associated with the irrational numbers. Irrational numbers always satisfy these two properties. The first property is that irrational numbers are always non-terminating. What is non-terminating? A number that does not terminate and that keeps going on and on is called a non-terminating number. Along with the number being non-terminating, the number should also be non-recurring for it to be an irrational number. So here, when we look at this example that we discussed, then we see that digit 2357 are reoccurring in the same pattern. Non-recurring means they should not reappear in the same particular pattern. But since here the digits are reappearing in the pattern, therefore it does not qualify the second property of a rational number and hence falls in the category of rational number. So irrational numbers must satisfy these two categories. Some examples of irrational numbers could be numbers like 1.2357192025 and so on, keeps going on and on. There is no particular pattern in which the digits are reappearing. So such a number we categorize as irrational numbers. Some good examples of irrational numbers could be the values like square root of 2, square root of 3, square root of 5, square root of 7, etc. Here I have written square root of only the prime numbers, which of course are irrational numbers. But it does not mean that the square root of non-prime numbers are not irrational. Square root of 6 also is an irrational numbers. Now, I'm going to discuss a very important and interesting example here. There is a number that's pi. Pi is a number that we use in area calculation of circle and at so many other things. So you have to first think which category does does this pi fall in, whether rational or irrational. Such questions are important and interesting because GMAT always tries to trick the students around things which are not appropriately understood. For example, many of us know that pi has a value which is equal to 22/7. But not everyone knows that the actual value of pi is actually not 22/7. Because if people knew that pi is only 22/7, they would probably categorize it as rational number because 22/7 can be written in the form of p by q. It is in the form of p by q, hence it should fall in rational number. But the fact is, the actual value of pi is not 22/7. The actual value of pi is 3.141592 something something and non-terminating, non-recurring in nature. Pi was initially devised as the ratio of circumference to diameter, which was approximated, and then it came out to be 3.141592. A lot of research has been done. But to simplify the use of pi, mathematicians devised that 22/7 gives a very close value to the pi. Therefore, we have been using 22/7 as a value of pi, and we will continue to use the value of pi as 22/7. However, for our GMAT perspective, we should know that the actual value of pi is not 22/7. It's 3.1415, which is non-terminating, non-recurring in nature, and hence it falls in the category of irrational numbers. There are also several categories that I'll not be talking about much in detail. The reason is GMAT is not interested in them. For example, irrational number further has two categories which can be defined as algebraic irrational number and transcendental irrational number. But we are not interested in these things. Transcendental pi is actually a kind of transcendental irrational number, and root 2, root 3 are the values of algebraic irrational numbers. But we are not interested in them because the GMAT is not interested. So any term that I'm not discussing here in these videos clearly are not representing any question pertaining GMAT, related to GMAT. So you can simply discard all those terms. Every single term which is relevant for GMAT will be discussed in every video, in the videos that I'm making for you. So pi becomes a very important and interesting example. Please keep in mind that pi is an irrational number. It's not a rational number. Now, rational numbers can further be categorized into two categories. One is integers and second is fractions. So we understand what are integers, what are fractions. Most of us do. Integers are the numbers which are in the form of p by q, where q is always equal to 1. Fractions are the values which are in the form of p by q, but q is not equal to 1, q is something else, where p and q are both integers, and obviously q is not 0. So fractions are the numbers like 1 by 2, 2 by 3, 3 by 2. These are the fractions. Integers are 1, 2, 3, 4, 0, minus 1, minus 2, minus 3, minus 4. That is. Integers further have categories like positive integers, negative integers, even integers, odd integers. We should understand what are positive integers. To the right of 0, every integer is a positive integer. To the left of 0, every integer is a negative integer. If an integer is divisible by 2, it's even integer. If the integer leaves remainder 1 when divided by 2, is called an odd integer. These are several definitions. Now comes the important question. The question is 0, as we know. Think about it, whether it's a positive integer or negative integer or none of these two. And likewise, think about whether 0 is even integer, odd integer, or none of these. Now, if you have given it a thought, you probably have an answer. Now, let me tell you what the correct answer is. 0 is neither positive nor negative, so none is the right thing, and 0 is considered an even integer. 0 is divisible by 2, and the quotient is 0 as well as the remainder is 0. So 0 becomes another very important example when we talk about the even integers and non-negative integers. Yep, non-negative, that's a term that I wanted to bring in picture. Integers, positive integers essentially. In the integers, these are two terms, not exactly the categories that I'm discussing. One term is used the positive integers, and on the other hand, we use the term non-negative integer. It's very important for us to understand that what is the difference between the two terms. So the only difference is that positive integers start from 1. 1, 2, 3, 4, etc. These are all positive integers, whereas non-negative integers start from 0. Understand this thing, 0 is the only difference, and this is a very significant difference. Any question creator of GMAT, when uses the term non-negative, then the only thing they keep in mind is 0. They always want to trick you around the 0 number. Therefore, be very cautious when you're thinking of non-negative integers. 0 is neither positive nor negative, but it's an even integer, right? Now, positive integers further can be categorized into three broad categories. One category is entirely enjoyed by 1. Second category is enjoyed by prime numbers. Third category is enjoyed by the term composite numbers. Now, 1 is entirely one of the categories because 1 is the only positive integer which has exactly one factor. 1 is the only factor of 1. Prime numbers are, on the other hand, those numbers which have exactly 2 factors. And composite numbers are the numbers which have greater than 2 factors. So here, these two categories are very important for us to understand, and we should also note that 1 is neither prime nor a composite number. The good examples of prime numbers could be the numbers like 2, 3, 5, 7, 11, 13, 17, 19, etc. We should know a couple of prime numbers because the prime number is one of the most interesting and most used terms in the number property questions. Therefore, we should know a couple of prime numbers for sure. Composite numbers, on the other hand, are all the positive integers other than 1 and the prime numbers. So it's starting from 4, leaving 1, 2, 3, and 5. Next number we have 6, leaving 7. We have 8, 9, 10, 12, 14, 15, 16, etc. These are all composite numbers. I hope that makes sense. Now, if you have taken your notes, then I'll quickly erase this screen and maybe start with a newer screen. Now, I'm not done with the terminology. There is 1 or 2 more terms that I want to discuss. Now, clearing this, let's start. Last I discussed was composite numbers. Right. When we see the composite numbers, there are also further terms. One term especially important for us is perfect numbers, because in past there have been questions based on perfect numbers. Discussing this term is even more important because some people tend to get confused between perfect numbers and perfect squares. So understand this thing, perfect squares are not perfect numbers. Perfect squares are squares of integer, for example 1, which is 1 square, 4, which is 2 square, 9, which is 3 square, 16, 25, 36, 49, etc. These are the squares of integers, therefore we call them perfect squares. Perfect numbers, on the other hand, are some specific numbers. These numbers are defined in a way that sum of all factors of the number is equal to twice the number. Let's understand this thing through some examples. For example, if we start from 6, we can think of the factors of 6. Whenever you are thinking about factor of any number, it's very important that you think about them in increasing order, starting from 1, and you stop at the number itself. So starting from 6, we understand, it's starting from 1, 2, 3, and 6 will be the factors of 6. If you add them up, so 1 plus 2 plus 3 plus 6 becomes 12, which is twice the number. Hence, 6 becomes a perfect number. Likewise, there is another example that we can discuss, that is 28. What are the factors of 28? Think for a second, and then I'm writing it here. 1, 2, 4, 7, 14, 28. If you add them up, the sum becomes equal to 56, which is again twice the number. So 28 also is a perfect number. 6 and 28 are the only first two perfect numbers that we should be concerned about. The reason is the next perfect numbers are way too big for GMAT to consider for the questions. For example, after 28, the next perfect number is 496. After 496, the next perfect number will be 8128. Next perfect number will be even bigger. So these numbers GMAT cannot get into because we cannot find out too many factors of this number to judge whether the number is a perfect number or not. So 6 and 28 are the only perfect numbers that we should concern ourselves about, right? So here, the basic terminology part gets over, and now we'll start with a couple of examples. So now, if you have no problem till here, then let's look at the very first question. I'm starting with the data sufficiency question. I'll be making how to deal with data sufficiency question. I'll make a separate video for it. However, if you are well acquainted with the data sufficiency question, we can proceed further and maybe discuss this question. Now, clearing this board. GMAT is quite interested in the questions like this. For example, question says if x is a non-negative integer, then find the value of x. That's the question. The first statement is x squared minus 5x plus 6 is equal to 0. The second statement is x squared is equal to 3x. I'll expect you to take a minute, try to answer this question, pause this video. Every time when you see a question, it's always good to just give it a try by pausing the video and then coming up with your answer. Whether you have an answer or not, then you should proceed and then see the explanation here. I think that will enrich your learning and experience both. I am quickly explaining the options for the people who do not remember the options as of now or who are just starting the GMAT preparation. Option A says that the first statement alone is sufficient, but the second statement alone is not sufficient. First alone is sufficient and second is not sufficient. B option says that second statement alone is sufficient, but the first statement alone is not sufficient. C option says that the statements together are sufficient, but individually the statements are not sufficient. D option says that each statement alone is sufficient to answer the question. And E option says that statements even together are not sufficient. Even together, not sufficient. Take a second, try to answer this question. I am quickly explaining this thing here. When you simplify the first statement, you have to factorize this kind of quadratic equation. 6 multiplied by 1 is 6, so the 5 has to be broken up into two numbers such that their sum or difference is 5 and the product is 6. So x squared minus 2x minus 3x plus 6 equal to 0 is the breaker, because 2 times 3 is 6 and 2 plus 3 is 5, which we can write further x into x minus 2 minus 3 common, x minus 2 is equal to 0, which gives us that x minus 2 times x minus 3 equal to 0. That is, x is either 2 or 3. Now this question is asking the value of x, and 2 and 3 both are the values of x. So we are not sure which value should we answer to the question. So we say that the first statement alone is not sufficient because it does not answer uniquely to the question. The moment we say the first statement alone is not sufficient, we can eliminate option like option A, option D, the first. Now, let's look at the second statement. Some of us answer the second statement in this way. X squared minus x squared is equal to 3x, so x cancelled out and x is equal to 3. You can quickly write that this will be a wrong thing to do, especially in this question. Why? Because when you cancel out the variables like this, the possible solution of x, which could be 0 as well, also gets eliminated. Therefore, this is a wrong thing when you do not know whether the variable is non-zero or not. If the variable is non-zero, it's fine, but if you do not know whether it's non-zero or not, then it's not a correct thing. Here the question says it's non-negative, which means it can be 0 as well, so it will be wrong. So what you do instead is, you say x squared minus 3x equal to 0, you take x common, x minus 3 equal to 0, and then you say that x is either 0 or 3. You still have two values of x, so you say the second statement also is not sufficient. So with this thing, the second option also gets eliminated. Now we are left with only option C and E. That means we have to just check whether together they are sufficient or together also they are not sufficient. Now when we combine the two, we see that there is only one common solution here between the first and second statement, which is x equal to 3. So we say the value of x has to be uniquely 3, and therefore statements together seem sufficient. So the answer becomes option C in this case. Now, why was this question important? Because there is one mistake that I have highlighted that some of us make. Do not make this mistake. Now, the second thing which we want to learn from this question is a little variation. What if I gave you that x instead of non-negative is a positive integer? Think for the second, will it change the answer of the question in any way? Now, if you have given it a thought, you should understand that now, after making this a small change, the answer becomes option B. Why? Because the second statement says x is either 0 or 3. But since 0 is not positive, so the only value we are left with from the second statement is 3. So the second statement itself uniquely gives us the value of x, and it is sufficient to answer the question. So the answer in that case becomes B option, which says second statement alone is sufficient, but first is not. So this example also helps us understand why we actually invested that much time in learning the basic terminologies, right? So the terms are very important. The appropriate comprehension of the question and the terms used in it is very, very important. If you misinterpret them, you will you're very likely to make mistakes in the questions. So please keep working on these terminologies, and I think in the next video I'll be discussing more about it. That was the first part. I'll stop here. Thank you so much.